The Dial of Disappointment. This is the Frankford Arsenal hand priming tool, and it appears to be a well-constructed tool with numerous shell holders for various calibers, a large and small priming rod, and a primer tray, brief instructions, and a guide for shell holders for different calibers. The problem I had relatively quickly in using this as a brand new tool is that the dial would freeze up, and turning the dial left or right adjusts the seating depth of the primer by about 1/1000th of an inch. And when I tested it, there were about 32 clicks between left and right, so it gives you very fine control. However, the dial has locked up, and I've disassembled and reassembled this numerous times, freeing the dial momentarily, but it locks up again. And what this video is about is to disassemble and show what's going on and to fix the dial once and for all. The first step is to remove the shell holder and the priming rod, and then remove the 8 screws that hold the two halves together. I've removed the priming rod, spring, sleeve, and shell holder. And to remove the screws, you'll need a 5/64 Allen wrench. The screws are all the same size, so you don't need to worry about keeping them in order. Before I separate the two halves, I want to demonstrate that the dial still does not turn. It's stuck. And when you reassemble, it's important to, before you put the screws back in, it's important to verify that the dial will turn. The way this is designed is that there is a dial and it's connected to a fixed and hollow shaft, and there's threads at this end, threads at this end, and there are 2 captive nuts at the threaded ends, and as you turn the dial to the left, the dial and its shaft will go down. As you turn the dial to the right, the dial and the shaft will go up. The nuts won't move. Both the dial and the shaft will move up and down. And additionally, there is what I will call a center rod, roughly shaped like that. And the center rod goes into the shaft, comes out here. And what stops the center rod from moving is the end of the shaft, not the nut. So as the dial is turned left or right, and the dial and the shaft together move up and down, that will control how far this center rod can be pushed up by the plunger on the handle. If you move the dial to the left and the shaft and dial go down, then this center rod will not be able to rise as high when you press the handle as if you were to turn the dial to the right and raise the shaft. That will allow this center rod to go higher, and that's basically what's controlling your seating depth, because right here is where you're priming what Frankford calls the priming pin. I call it the priming rod, and here's your shell holder up here. So the critical thing is that the dial and the shaft, hollow shaft with this center rod, is what really controls your depth. And again, the center rod can only go as high as the bottom of that shaft. You can see the two captive nuts here, the dial, and this is the center rod, which will rise at the top. As you press down on the handle, the center rod is pushed up by the plunger, and you can see it rising out of the center rod, and it stops at the end of the shaft. We need to find out why the dial does not turn to raise and lower the shaft. Let's look at that in a little bit more detail. Let's simplify what we're looking at here. We have this, and remove the lower nut and the upper one, and that leaves us with this. And it appears to be symmetrical, but not really, because there are a lot more threads on that end than on the other. So first you'll see in the bottom half the two areas here and up here where the nuts are held captive. And in the center there's this little flat spring that the dial rotates against. And the longer end is now going to be pointed upward towards the priming end of the tool, and this is the bottom of the tool. It makes sense that this shorter end should be oriented there, because it allows the plunger actually to push a little bit further. I think the two most important things are that the vertex of the nut is basically vertical, so that the vertex will fit here in the top half and down here in the bottom half, because if it's not right at the very top, the nut will not settle properly, and as I said, you won't be able to get the two halves together. The other important thing is that there should be some freedom of movement, and when you put the screws back on the shaft, they shouldn't be so far apart that they don't fit in the slots here. There is some room for play, and there should be, when you put them on, you should get it just so that they will just drop in, and again, also not butted up against the center part of the dial here. So nothing is really tight. In fact, you can even see the gap there and less of a gap there. Here's a better view. And so I can turn the dial. I can all the way to one end and then all the way to the other end. And I can feel it come to a stop, but it's relatively easy to get it to come back and go to that end. So there's full freedom of movement here. So I will put this back in and then put the top half on, and we'll see if the dial still moves. Okay, so this plunger actually needs to be put in with the top half off. Before final assembly, I want to show how this is fit in here. I have the dial centered in its slot there, and I have the two nuts positioned so that the vertex is at the top, and there is actually a bit of a gap between the shaft and the nut. That may show the gap a little bit better. So I don't want anything butted up against the nut. Now I'm going to put it back together and give it a try. and the dial still moves back and forth. So no problem there. Time to put the screws back in. It has been reassembled again, and I have the dial set to its lowest setting, and I'm not going to push it too hard against that low setting. And you can see that's a lot better. Let's put it up a little bit higher, and again, I'm not going to push it up hard against that stop. It's quite a range of travel there. And you can see that's a lot higher. So I think that has solved the problem. Thanks for watching.